This is part 2 of our video on graphing exponential functions. And in the previous part, we made tables of values for a variety of different functions. You were supposed to finish this one on your own, so you can check the numbers to see if yours match, and then plot them on the graph, which is starting to get really messy. So this is the last one. It was tricky to plot those points because they were all decimals and they were fairly small. So I just had a couple of points to plot there. So what we want to try to figure out is what happens when we put a number in front of our, in this case, 2 to the x. So when I put a negative in front, that gave me this graph down here. And I noticed that it was the same shape as the black one, the original one, except it was upside down. So whatever it did here on the first one, it flipped it upside down. Now the green one we multiplied by 2, so it is very, very hard to tell. I'm going to zoom in a little here on this graph, but the black one, which is here, and the green one, which is here, the graph ended up kind of shrinking in a little bit. So it made it a little bit thinner this way. It just kind of squeezed it a little, kind of stretched it in this direction. So it's a little bit, very hard to tell, but it's a little bit thinner. Okay, the red one, if I take a look at the red one, it also got pushed over this way a little bit. So I know that here it looks a little different, but it's kind of like it's been either a little smushed that way, but mostly it's just been stretched going up. Our numbers go up a little bit higher. And then when I take a look at the 2 blue ones, the light blue one and the dark blue one, they're starting to move out on the other side, and they're a little bit wider. So it's hard to tell on exponentials because the graphs are a little different and the points climb so quickly. But this really does the same thing as it does with parabolas. We're going to take a look at our transformation values here. We've seen k before, we've seen h before, and now we're going to talk about what happens when you put an a in front of your function. So I'm going to mark k, do that one in red, we'll do h in blue, and we'll do a in green. So the k, what does it do? We learned this one yesterday's lesson. It moves your graph up and down. Positive moves it up, and a negative moves it down. We also discovered that it controlled the asymptote. Whatever that number is where your asymptote is going to be. And if you don't have a number at all, it's 0. The number inside the bracket we discussed last time moves the graph left and right. A positive goes to the left, and a negative moves it to the right. Now the new part, and it's not so terribly new, it's new to exponentials, but it is something we have seen before with the parabolas. Putting a number in front and multiplying either flips the graph upside down, that's called a reflection, or it can make it a little bit thinner or a little bit wider, which would be a stretch or a compression. So what makes a reflection? Putting a negative in front of our base function is always going to make it a reflection. If it's a stretch, that's usually a number bigger than 1. Well, it's always a number bigger than 1. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Today I'm going to just pick the number 2 as an example. And a compression is going to be something where it's less than 1. So a fraction or a decimal, so say 1/2 or 1/3 or 0.5. So I'm going to just say a half as my example for today. So what we're going to do is we're going to take a look at 3 graphs here. We've got y equals 3 to the power of x. We've got 2 times 3 to the power of x plus 6 minus 10. And negative 1/6 times 3 to the power of x minus 1 plus 5. Now the first thing I do notice in all of these is that they do have the same base. You can find the base by looking at your looking at your equation and looking at what has the exponent. So the exponent is sitting on the 3 here, right? It's a 3 to the x, 3 to the x plus 6, let me zoom in a little, and 3 to the x minus 1. So the base function for my graph is going to be 3 to the x. So whenever we're graphing one of these, we always start with the base function, and then we apply our transformations to figure out what the new graph is going to look like. So the base function 3 to the power of x, we've made a lot of tables of values already. We've done a lot for 2 to the power of x, but we're going to try doing 3 this time. So I like to start at the bottom. 3 to the power of 4 is 81. 3 to the power of 3 is 27. 3 to the power of 2 is 9. 3 to the power of 1 is 3. 3 to the power of 0, anything to the 0 is always 1. 3 to the negative 1. So I'm going to look at 3 to the positive 1, and then I know a negative exponent makes a fraction. It has a flipping over action. So it takes that 3, it flips it over to make it a 1 over 3. And then for the negative 2, I take a look at positive 2, and I make it a fraction, so 1 over 9. For negative 3, I look at positive 3 and make that a fraction, so 1 over 27. And for the negative 4, same thing. We get 1 over 81. I think I'm going to wait and plot all of these at the end, and we're going to focus just on doing the points first. So for this next graph, what I want to do is take a look at all the transformations and figure out what they do. So I have a minus 10. I have a plus 6 inside the bracket, and I have a 2 out in front. So I like to start with the parts at the end. I find those the easiest. So minus 10 is going to move the graph down 10. It also tells me that my asymptote will be at negative 10. I've got x plus 6. That's going to move the graph to the left 6. That's what that plus does. And then out front, I have a 2. So I know this is going to be a stretch because it's bigger than 1. And I say that it's a stretch of 2 because it's going to be 2 times bigger or 2 times taller. Just zoomed in a little to make this easier. So then what I want to do is figure out for each of the transformations, is it changing my x values or my y values? So I'm going to start with the down 10. The down 10 moves up and down, so vertically, which means it's going to change the y. So if I'm going down 10, I'm going to take my y and subtract 10. Now, left 6 moves side to side, so it's actually moving it to the left 6, so that's going to change the x. And whatever we see in the bracket is always wrong, so we always do the opposite of what we see. So a plus 6 becomes minus 6. And then this is the new part for us, a stretch of 2. We didn't really talk about it, but these are all vertical stretches. So up and down. So we're going to end up stretching the y value. So we're going to take my y value and stretch it by 2. And I'm going to do that by multiplying by 2. So there's actually 2 things that I'm going to do to the y value and 1 thing that I'm going to do to my x value. So I am going to start with the x. Let's see if I can slide this over a little bit here. I don't know if we can see them. There we go. And I just like to cover up the ones that I've already, I don't want to use the wrong one. So I'm going to take each of my x values and subtract 6. I think we've done this before. So negative 4 take away 6 is negative 10, and then negative 9, negative 2 minus 6 is negative 8, negative 1 minus 6 is negative 7, let's keep going, negative 6, negative 5, negative 4, 3 take away 6 is negative 3, and 4 take away 6 is negative 2. Then I'm going to do the other side. If I take a look here, I'm actually going to cover up that part so I don't use the wrong one. Now we have to follow order of operations, which tells us we need to multiply before we add and subtract. So we're going to do 1 over 81 times 2 and then subtract 10. So I usually like to start with the whole numbers, but I'm feeling adventurous today. I'm thinking maybe I'll just use my calculator, and I'll show you the first one and then I'll do it off screen. So we're going to do 1 divided by 81, so to get that number in, and then I'm going to do times 2 and then minus 10. And I get this beautiful looking decimal, and I'm going to just try to write it down to the best of my ability here. So I'm going to write down negative 9.9. It was 7.5. So that 5 is going to push that 7 up to an 8. So 9.98. And then on the calculator, so I'm still doing it on the calculator just off screen here. I have 1 divided by 27, that's the next one down, times 2 minus 10, which is negative 9.92. Actually, it's going to round up to a 3 because it's 925. 1 divided by 9 times 2 minus 10 is negative 9.777, so negative 9.78. And then 1 divided by 3 times 2 minus 10 is negative 9.33333, or negative 9.33. 1 times 2 minus 10, at least I'm out of the decimals, is negative 8. 3 times 2 minus 10 is negative 4. 9 times 2 minus 10 is 8. 27 times 2 minus 10 is 44. And 81 times 2 minus 10 is 152. Okay, so our last one, before we plot all of our points, we're going to take a look at the last one here. We're going to do the exact same thing that we did. Okay, we're going to take our base function of 3 to the x, we're going to state all of our transformations, figure out if they affect the x or the y, and then take our values of 3 to the x from the earlier part. Let's just actually fold that over so I can see them. All right, we're going to take those numbers and then apply our transformations. So I have a number in front, I've got a number at the end, and I've got a number in the bracket. If I take a look at the number on the end, that plus 5 is going to go up 5. And when I move up 5, we are changing the y value. We're going up 5, so I'm going to add 5 to my y. That minus 1 inside the bracket is going to take the graph right 1. Moving right 1 moves it side to side, which changes your x value, and the bracket is always backwards, so if it says minus 1, we are going to do plus 1. Now there are two things going on here. I see that it's negative, which tells me this is a reflection. My graph is going to be upside down. And I see the 1 over 6, which tells me that this is going to be a compression. That's because it's a fraction. And there's a couple of ways you can say this. I like to say that it's a compression, sorry, I just want to take that down, of 6. So I'm going to say this is a compression of 6, which means it's 6 times flatter or 6 times wider than the original. Sometimes some of your teachers in grade 10 may have taught you to say that it's a compression of 1 over 6. That's okay, but I will write it a compression of 6. So since it's a compression, we're not going to multiply this time. We're actually going to do the opposite, and we're going to divide. So when we're stretching, we multiply, and when we're compressing, we divide. And to get the reflection in there, I'm not just going to divide by regular old 6. I'm going to divide by negative 6. So I'm going to get my calculator going, and you'll notice, hopefully you caught it, I wrote that on the wrong side. It doesn't change the x, it changes the y. So we're going to divide this by negative 6. Sorry about that. Okay, so let's calculate. First one, for x, we are just adding 1. So that's a relatively easy thing to do. I'm just going to take all of my x's and add 1. And we're just about to run out of time. So what I'm going to ask you to do is to, obviously the video is going to stop, so calculate yourself, and then when you start watching the next part of the video, you can check and see if your numbers match mine.